In this video, I'm gonna solve a linear differential equation. So the equation is x dy dx minus x squared y equals x squared. And I should mention it's a linear first order differential equation because of the term dy dx, so it's the first derivative. The very first step that you want to do when solving a linear differential equation is, let's write step 1, get dy dx with the coefficient 1. So divide equation 1, let's call equation 1, by x. So if we divide all the terms by x, I get dy dx minus x times y equals x. Step 2, identify p of x. So p of x is the function that is multiplied by y. So p of x in our case is negative x. Step 3, compute mu of x, which is equal to e to integral of p of x dx. And the reason why we want this mu of x is because it's a function that when we are going to multiply the equation, let's call this equation 2, when we multiply equation 2 by mu, we are going to obtain a perfect derivative on the left hand side. So let's compute it. E to integral of negative x dx, it's e to negative integral of x dx, it's x squared over 2. So there we go, we found it. Of course it's plus c, but e to the c is actually a constant, and the whole idea of multiplying by mu of x is you multiply the whole equation, which means you're going to end up with c on every term, which you can cancel. So we are not going to worry about any constant for the term mu of x. Step 4, multiply equation 2 by mu of x. So basically I'm going to multiply by e to negative x squared over 2. So our equation 2 is going to be dy dx times e to negative x squared over 2 minus x times e to negative x squared over 2 times y equals x times e to negative x squared over 2. So the left hand side, it's a perfect derivative, and that derivative is d dx times e, let's put y first, y times e to negative x squared over 2. So basically is this function times this function. If we differentiate it using the product rule, we are going to get exactly the left hand side. So you can try that. You can try to differentiate this term where y, of course, is a function of x, using the f times g, the product rule, f prime g plus f g prime. You are going to see, you're going to obtain exactly the left hand side, and equals the right hand side, which is x times e to negative x squared over 2. The next step, step 5, is integrate, let's call equation 3, with respect to x, which is our independent variable. So when we integrate, we get integral of the derivative, right? So we integrate, we put the differential. So integral with the derivative is going to give me just the function. So y times e to negative x squared over 2 equals integral of x times e to negative x squared over 2 dx. So the left, and now the next step is compute the integral and find, step 6, compute the integral and find y of x. So y times e to negative x squared over 2 equals, how do I calculate the integral? Well, one way is to use substitution. So u equals negative x squared over 2 du equals negative x dx. So we basically have integral of x dx, it's actually negative du, and then e to u. So y times e to negative x squared over 2 equals negative integral of e to u du, it's e to u, the simplest one, but u is negative x squared over 2. Don't forget to add the c. We are calculating an indefinite integral, so this time c is important. And I'm going to multiply e to negative x squared over 2 both sides, so we get y of x equals 1. Well, sorry about that. Backing up a bit, I'm going to multiply by e to positive x squared over 2, so that it's like I'm dividing by e to negative x squared over 2. So then I get on this side negative 1 plus c times e to x squared over 2. And this is it. We found out the explicit solution of the equation. But in the previous problem, in the previous video, we learned how to do separation of variables. So I'm going to check this problem that I did to see if it's separable and if I can check my answer using the method for separable equations. So the equation was check by separable equations. So the equation was x dy dx minus y times x squared equals x squared. So I'm going to move this on this side and I'm going to factor it out as well. I'm going to get 1 plus y. Then I'm going to divide both sides by x and I'm going to get dy dx equals x times 1 plus y. So if we multiply by dx and we divide by 1 plus y, the left hand side is going to be 1 over 1 plus y dy and the right hand side is going to be x dx. If we integrate both sides, we get ln of 1 plus y equals x squared over 2 plus c. So 1 plus y equals c e to x squared over 2. And y equals negative 1 plus c e to x squared over 2. How great is this? We actually checked our problem with separation of separable equations. I hope this helps.